This is a video for AQA Mechanics, Centre of Mass and Moments, section 2.5, which looks at couples. This diagram is illustrating a light rigid rod which has been subject to two forces which are equal and opposite. Now by light, this means that we have a situation where we can consider the mass to be equal to 0. And if we've got equal and opposite forces, then obviously the resultant force in the direction is going to be 0. However, if we take moments, then we can see that these forces produce a moment. So for example, about A, we can see that the moment would be equal to P, the force, multiplied by the distance, so P multiplied by D. And in fact, we can take moments about any point you like, and we'll see that there is a moment equal to P times D. This moment is referred to as a couple. So equal and opposite forces which are separated by a distance D give a couple which is equal to P multiplied by D. So in this question, the value of P is 20 newtons, and the length of the bar being 5 meters, we can easily calculate that the distance between the two forces is 2.5 meters. And therefore, the couple is equal to 20 multiplied by 2.5, which is equal to 50. Now the units of a couple must be the units of force, newtons, multiplied by distance, meters, so Newton meters. If we have a system of forces acting on an object, then it's possible to replace those forces by an equivalent single force acting at a point and a couple. We can calculate the value of the force by considering the resultant of the system of forces, and also then the moment of the forces about the point will give us the value of the couple. So let's look at that in a particular example. This question then shows two forces, 10 newtons and 50 newtons, which are acting as shown on the diagram, and we want to calculate the resultant force and couple that can replace these if the force is acting at point X. So first of all, to find the resultant force, we need to resolve the two forces 10 and 50 newtons in two directions and calculate resultant using Pythagoras Theorem. We can use any two directions we wish, but one obvious way would be to use the line which is on the diagram and the perpendicular, so that the 50 Newton force is in the line of the perpendicular, and we only need to then look at the 10 Newton, which will have components of 10 cos 60 along the line on the diagram and 10 sine 60 on the perpendicular. Therefore, the totals that we have for our forces are 10 cosine 60 in this direction, and then in this direction 50 plus the 10 sine 60 degrees. Then we can calculate using Pythagoras' theorem the value of the resultant of those, which gives us our value of P that we want for the force acting at X. Well, cosine 60 is a half, so 10 cos 60 is equal to 5, and sine 60 is equal to root 3 over 2, so this is 50 plus 5 root 3. Therefore, P will be equal to the square root of 5 squared and then 50 plus 5 root 3 all squared. And P turns out to be 58.9 newtons to 1 decimal place. The angle at which the force acts can be found from this diagram here, theta, and so theta is then tan to the minus 1 of the two sides divided by each other, so 50 plus 5 root 3 divided by 5, and that turns out to be 85 degrees. So 85 degrees to the line which is drawn on the diagram. To calculate the couple, we need to take moments about x. So taking moments about x, the anti-clockwise moment is given by the 50, so 50 multiplied by 0.3, and then there's a clockwise moment which is equal to 10, and the value here of that angle is 30 degrees. So we have minus 10 cosine 30 degrees multiplied by 0.7. The other component is acting along the line which goes through x and therefore has 0 moment. So that's our total moment and therefore couple, and this turns out to be equal to 8.94 Newton meters. So we found that the system of forces is equivalent to a single force P acting at x, which is equal to 58.9 newtons, and a couple which is equal to 8.94 Newton meters. Well, this is the end of this video, and indeed the end of the series of videos in Centre of Mass and Moments section 2.